Hi, welcome to my channel. In this video, we want to find all positive solutions of the following system of equations. x1 plus 1 over x2 equals 6, x2 plus 1 over x3 equals 2/3, x3 plus 1 over x4 equals 6, and x4 plus 1 over x1 equals 2/3. First, let's prove the following inequality. If x and y are greater than 0, then x plus y is greater than or equal to 2 times square root of xy, with equality if and only if x equals y. For the proof, consider the expression x plus y minus 2 times square root of xy. After rewriting x as square of x, y as square of y, and square root of xy as square root of x times square root of y, we can simplify the expression by using the identity a minus b whole square equals a square plus b square minus 2ab. For our case, a is square root of x, while b is square root of y. So the expression becomes square root of x minus square root of y whole square. Since the square of a real number is non-negative, our expression is greater than or equal to 0. With equality if and only if square root of x equals square root of y, or x equals y. By moving 2 times square root of xy to the other side, we obtain our desired inequality. Next, consider the left-hand side of the first equation. Making use of the inequality that we just proved, with x equals x1 and y equals 1 over x2, we have x1 plus 1 over x2 is greater than or equal to 2 square root of x1 over x2, with equality if and only if x1 equals 1 over x2. Similarly, we have x2 plus 1 over x3 is greater than or equal to 2 square root of x2 over x3, with equality if and only if x2 equals 1 over x3. The same pattern holds for the third and the fourth expression. Continuing, we multiply all these inequalities to obtain x1 plus 1 over x2 times x2 plus 1 over x3 times x3 plus 1 over x4 times x4 plus 1 over x1 is greater than or equal to 2 square root of x1 over x2 times 2 square root of x2 over x3 times 2 square root of x3 over x4 times 2 square root of x4 over x1. Following this, consider the left-hand side of this inequality. Since we are given the numerical values of these four terms, the left-hand side becomes 6 times 2/3 times 6 times 2/3, which equals 16. With the left-hand side equal to 16, we now examine the right-hand side of the inequality. The 4 copies of 2 gives us 2 to the power of 4, while the x2s cancel each other out, and similarly the x3s, the x4s, and the x1s cancel each other out. This leaves us with 2 to the power of 4, which equals 16. Therefore, the right-hand side also equals 16. And the inequality is in fact an equality. Recall that we obtain the inequality by multiplying all these inequalities. Therefore, all these inequalities are equalities instead. Recalling the conditions for these inequalities to be equalities, we thus have x1 equals 1 over x2, x2 equals 1 over x3, x3 equals 1 over x4, and x4 equals 1 over x1. Substituting x1 equals 1 over x2 into the first equation gives us 2x1 equals 6. Therefore, we have x1 equals 3. Substituting x2 equals 1 over x3 into the second equation gives us 2x2 equals 2/3. Therefore, we have x2 equals 1/3. Substituting x3 equals 1 over x4 into the third equation gives us 2x3 equals 6. Therefore, we have x3 equals 3. And lastly, substituting x4 equals 1 over x1 into the fourth equation gives us 2x4 equals 2/3. Therefore, we have x4 equals 1/3. Thus, the solution to our system of equations is x1 equals 3, x2 equals 1/3, x3 equals 3, and x4 equals 1/3. As an exercise, try to solve this system of equations and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.